All right, welcome everyone. Is the mic AGP? Are we okay on the mic? Are we okay on the mic? Check. Okay, thank you. Thanks very much. Okay, welcome everyone. This is a special meeting of City Council on Tuesday, January 23rd. Our meeting starting at 4 o'clock, located here at the Veterans Memorial Hall for our viewing members. Thank you. For the record, we do have a quorum. All members are present. We'll call a meeting to order. This is a review of the One Water Plan, including water supply evaluation criteria. And we're going to open the beginning of the meeting with public comment. And I'm looking in the audience, and for anybody who'd like for public comment at this time, I'm getting no takers for public comment at this point. And then when we get on to council, we'll have speaker slips. So I'll open and close public comment. Thanks very much. Thanks for attending. And we'll move on to our special meeting. This is the review of the One Water Plan, including the water supply evaluation. And tonight we have with us Damaris Hanson, our Environmental Programs Manager, and Joe from our wastewater plant, thanks, and Rob Livick. So we've got a full crew here. This is exciting. So we'll look to Rob to open it up for us and take away.
Thank you, Mr. Mayor. As you know, the One Water planning effort became a goal of City Council a couple of years ago to look at various options for the city's water supply, future water supply. In addition to that, we had some water master plans that were getting long in the tooth. So the basically industry standard is now to wrap those resource documents up into one package called One Water, which incorporates looking at water supply, water treatment, water conveyance, sanitary sewer systems, and stormwater systems holistically. We have Eric Caceres from Carollo Engineers, the project manager. He's going to start off the presentation, and his colleague Lydia, who I cannot remember, Holmes, thank you. I heard that from somewhere. Here to assist in the water supply evaluation portion of the presentation. Apologize to council for not having copies for you. We need to fix this room so that presentations are actually viewable. I don't know how we've made it so many years like this, but we have. So I think the city manager and the city attorney have a good view of the presentation, but for the rest of us, especially on this side of the room in the council, not so good. With that, I'm going to bring Eric up to the podium to kick off the presentation, and follow the presentation. We'll have some questions. In fact, interrupt at any time. We may get to a slide that talks about prioritization. We might want to linger there and have a discussion about that. Eric, thank you.
Great. Thank you, Rob. Mr. Mayor, members of council, city staff, thank you for having us here this afternoon to present on the kind of an overview of the One Water planning effort and kind of a status update of where it is currently. Again, my name is Eric Caceres. I'm project manager for the project with Carollo Engineers. So as Rob mentioned, this One Water plan is really coming out of this One Water concept that's been adopted by kind of as the new industry standard in looking at a city or an agency's water utilities and water resources. So I listed over here on the right-hand side of the slide a number of other communities in California that are kind of taking the similar approach, have taken the similar approach. I think the one third down from the top below Santa Barbara and Oxnard, that's Los Angeles, City of Los Angeles went through and just finished this large kind of One Water planning concept for their water resources. And so it's what we're embarking on here for the City of Morro Bay is very similar in scope, smaller in size, obviously, to what they have done. And so the city's really following following the footsteps and following the industry trend and how these things are being looked at. So real quick, what are the goals and objectives of the One Water plan? It's really to look at the necessary capital and maintenance improvements for the city's infrastructure, kind of outside of the wastewater treatment plant, but all of the pipes and the pump stations and the tanks and all the underground utilities that the city currently owns and operates. And then on the flip side of that, it's really to look at the city's water portfolio and look where the city currently sits, what the future water demand projections are going to look like, and then how is the city going to meet those demand objectives. And then there's also the side benefit of the One Water Plan informing the general plan and the local coastal plan updates that are currently going on. So really the One Water Plan plays the central role in the city's water utility or water resource utility planning. So with the exception of two of these bubbles, really the wastewater facility master plan and the master reclamation plan, the One Water Plan is going to generate all these different things, or all these different things are included in the One Water Plan. But it is important to note the wastewater facility master plan and the master reclamation plan do play a key role in influencing this One Water Plan and vice versa. So just showing kind of the central nature of the effort that we're undertaking. So really the goals of the meeting here today are to review the individual components of the One Water Plan, and from a high level they can really be broken down into these four elements. There's a water master planning component, a collection system or sanitary sewer master planning component, the stormwater master planning component, and then the water supply evaluation component, looking at the different supply options. We want to really review the components of each of these elements and then talk about the status of each of these, kind of what have we done and what do we have yet to do. So just a couple of slides to start out talking about the city's historical water supply. So the city, for the fairly recent future, has relied on almost solely on state water for its water. You have an allocation of about 1,300 acre feet, which more than covers what the city's current demands are. You also have two well fields that are available to you, the Morro Valley and the Chorro Valley, and infrastructure associated with those. And then you have the ocean desal facility, which is really kind of permitted for emergency use at this time. In terms of the city's water infrastructure outside of the underground utilities, you've got a water treatment plant out there at the city's courtyard, and it's really broken down into two components: a brackish water RO system that's used to treat the water coming from the Morro Valley at this point in time. It's in good condition. The RO racks, which is kind of the heart of the system, and some of the associated electrical components were recently upgraded and could potentially be reused in the future. But there is this consideration of kind of relocation of the facility based on information obtained from the regional board in terms of flooding concerns and those kinds of things. So that's kind of the state of affairs on the brackish water RO side. And then we embarked on a fairly exhaustive evaluation of the seawater desal facility when we first started the project back over in about June or July of this year. And we took a look, and there's really, it's pretty aged infrastructure. So there's some issues there with the seawater intake wells and also with the facilities that are there. And then major upgrades would need to be undertaken to increase the yield or to address some of the regional board's concerns, not only with the location of the treatment facilities, but also some things with the outfall if it was to be used for kind of a long-term or a regular water supply for the city. Again, there's a FEMA flood map that just kind of shows the location of the existing courtyard and the water treatment plant. So in terms of the Morro well field, the city has a permitted capacity of about 581 acre feet, which is roughly half of the demand. TDS has been seasonally exceeded about 1,000 milligrams per liter, but the issue really on the Morro well field is the nitrates. And then on the Chorro well field, which hasn't been really used in recent time, the permitted yield is about 1,100 acre feet, which is pretty much the city's full demand. But there's some limitations on that right there on Chorro Creek. One of the big ones is the minimum stream flow in Chorro Creek has to be above 1.4 CFS in order for the city to be able to use that water. And again, TDS has been relatively low, but there's been some problems with nitrates in the past. So just some things to consider. And then the desal facility, it's got a permitted capacity of about 645 acre-feet now. As we discussed, it's really only used and is really only permitted for emergency use at this point in time. Really, it treats a relatively low TDS in terms of the water that it treats from the ocean. It's more of a brackish water that it's treated, that it pulls in and treats from the ocean. And then again, it's really only used for emergency purposes, but we are looking at in the One Water plan how that could be used in a more permanent installation and what would need to be done in order to permit that and make that a possibility. So we'll switch gears a little bit and talk a little bit about the infrastructure master planning components before we move on to the water supply. So remember some of that stuff when we get back to the water supply evaluation. So really the water and collection system master plan components, we're going to touch on those first. They're pretty similar in terms of the different activities that we go through in order to complete those. We really start with a pretty exhaustive data analysis. So we've been hounding the city for a lot of background data over the last few months. We spent 3 or 4 days in the field going and looking at the individual infrastructure associated with the water and the sewer systems, the lift stations, the booster pump stations, the tanks. And then we take a look at the historical and projected water demand and wastewater generation. So currently, what is the city using in terms of water? How much wastewater is it generating? Then we go through and we do create hydraulic models of both the water distribution system and the collection system. And we calibrate those models based on flow data. We come through and we develop planning and design criteria. We've been working with the city over the last month or two with city staff to take a look at the planning criteria that have been used in previous master plans, assess whether that's valid to use that, and then come up with either using the same planning criteria or updating that planning criteria for this iteration of these master plans. We then take and we look at the model and we look at how the model performs in light of the city's existing water demands, or on the wastewater side, the existing wastewater flows. And we identify deficiencies based on that planning criteria. So are we exceeding the allowable depth in the sewer pipeline? Are we exceeding the allowable velocity in this water pipeline? And we identify those deficiencies, both for the existing system or under existing conditions and under future conditions. We come up with recommended improvements to essentially in order to mitigate those deficiencies. And then from there, we develop a comprehensive capital improvement program that identifies costs for all of those different projects that come out of that evaluation. And then we wrap all that up into the one water plan. So this is just a screenshot here of the water model. Again, we model all of the different pipelines within the city system. And then all of the above-ground infrastructure, including the tanks. Work with Joe and his staff to figure out how those tanks and pump stations and wells are all operated, and all of that information is included in the model in order to calibrate it.
If I might interrupt, Eric, and just so we're clear, the reason we do this modeling is so that we can run various scenarios on water system demand, future demand, fire flow demand to develop that capital improvement project that we'll need to budget for and plan for in future years.
Thanks, Rob. So this is kind of an exhaustive list of all the things that we need to do to complete the water master plan. And you'll see up here, we've gone through a lot of the initial efforts, and we've actually made a lot of progress on the water master planning side of the house. So we go through the data collection, which I talked about, the demand analysis, planning criteria. We've gone through now and we've taken a look at the city's existing system under the existing demand conditions and the planning criteria we've identified in order to figure out what existing deficiencies exist in the existing system. Really, the next steps will be, and what we're currently working on right now, is looking at the existing system under future conditions. And so something that's not deficient today but may be deficient in 2030, those are the things that we're identifying now. And again, we then figure out all the recommended improvements to mitigate those deficiencies and come up with a cost or a capital improvement plan associated with the water facilities that would need to be installed over roughly the next 20 years. So on the sewer model side, things are pretty similar in terms of the way that we look at the collection system. again, a long, exhaustive list, and we're kind of just one step behind on the collection system at this point in time. We're actually in the middle of looking at and evaluating the city's existing system. So that is what the effort that we're currently going through now. Again, we'll go look at the future system, come up with that capital improvement plan, and then wrap all that up into the one water plan for those components.
Okay. Can I ask a question?
Sure.
Can you tell us how you evaluate these systems? I mean, what is your process for doing that?
Sure. So we look, once we build the model, we sit and meet with city staff, and that's where we come up with the planning criteria. So a good example of planning criteria is on the collection system side. There's a number of different ways to determine if something is quote-unquote deficient, and that would be, does the pipe at max flow conditions, is the pipe flowing 3/4 full? Is the pipe flowing completely full? Is the pipe flowing, is it surcharging by a few feet? Is sewage spilling onto the street? Those kinds of things. And so what we do is we identify what that criteria is. And for example, we might say, okay, well, the criteria is we're going to let that pipe flow completely full during peak flow, and we're going to let it surcharge into the manhole by 2 feet. That becomes the mark at which we're measuring all of the individual pipes within the city. So those pipes that are exceeding that condition would be quote-unquote deficient.
So are you actually using cameras? I mean, how are you investigating these pipes?
So it's all in a computer-based model. So we've gone out and we've taken and we've modeled the system. We've recreated the system within the modeling software. On the collection system side, we've gone through and we had a flow monitoring study that was done. And so that information from the flow monitoring study is what we use to calibrate the model. So we have real-world data. If we put this flow through the system, here's what the levels and velocity should be in all the different pipelines. And we get the model to mimic those conditions, and that's how we calibrate it. So then that allows us to then apply these different theoretical conditions, future conditions to the system.
Thank you.
In addition to that, they have reviewed the city's video logs to look at the physical defects with the pipe. So there are pipes in town that there may be some cracks, there may be offset joints where the pipe isn't aligned anymore. There may be situations where the house lateral wasn't connected to the pipe the way we would do it today. So all that is taken into consideration for evaluation of the system.
Yeah.
But we do know these things, is my question.
We know them at a point in time. We don't continuously
Right. Okay.
know them.
All right, thanks.
Yeah, and then just a couple examples on the water side. I don't know, some people might have seen Joe and his crew out there, but we actually install pressure loggers on different hydrants, and so that we can see, based on what's going on in the system, what are the different pressures that we're seeing throughout the system, and that's another way for us to be able to calibrate that model to say, okay, if we apply this type of demand to the system, which was the same demand that we got on July 3rd, are we getting the same pressures throughout the system? And that's how we determine if we've, quote-unquote, calibrated the model and we've got something that's mimicking what's happening in the field. Any other questions?
Any other questions? No, that's okay. All right. Are there more to continue on here, Rob?
I think
Yeah,
Eric
I've got a couple more slides. I'm going to talk a little bit about stormwater, and then I'm going to let Lydia take over and talk about
All right, great. Thanks.
talk about water supply. So on the stormwater master plan, it's a little bit different. As you can imagine, the city's stormwater infrastructure is not as maybe complex as both the water and the sewer side in terms of the number of pipes in the ground and the stormwater pump stations and all those different things. But we do go through the same planning analysis. We do go through a number of field investigations, so spend a couple days out here with Damaris. And then we look at the stormwater flow projections. We develop a stormwater hydrologic model, so a little bit different than the models that we're talking about from the water and the collection system side. And then we do an existing system evaluation, so we apply design storms to the system to see how the stormwater system will react to those. And then we go through and do the same kind of exercise. We've got established design criteria that say if this happens, then this is deficient. And so we come up with those deficiencies, the recommended improvements to mitigate those deficiencies, and then what are the costs of those improvements. So the stormwater model is a little bit different. It's constructed in a different modeling software. It's really based on existing GIS data. We look at the as-built and the site visits, and this was one where we've got to do a little bit more sleuthing to figure out exactly what's going on with the stormwater system and what the infrastructure looks like. So it took a little bit longer, and so really what we've got in progress right now is we've digitized the storm drain facilities into the model. We're still filling in a few existing data gaps, but we've made some pretty good headway. We really got the hydrologic model constructed, and what we're looking at now is applying those design storms and evaluating the existing system. So any questions kind of on the water, sewer, and storm outside of the water supply evaluation component? But
Yes, I have a question.
Yeah.
On the wastewater side, is your modeling designed to determine, I know I think Rob said you actually have gone in and looked at the condition of the pipes and that, exfiltration and or if there's leaking sewage out of those pipes, and if that is significant, and can you quantify that and determine that as part of your analysis?
That's something that we're going to address in the report, definitely. One of the things that we did go through and look at, I want to say we do look at the footage, some of the camera footage, especially when we know where there's some problem areas. We're not doing a kind of a full-blown condition assessment of all the pipes that are in the ground. That's a kind of a different, another level of analysis to look at what the actual condition of those are. But we did do an I&I analysis, so that was one of the things that we recently completed. Is based on the flow monitoring data and the model that we've got now, we've been able to pinpoint kind of the hot spots within town that have a larger infiltration and inflow response, and kind of what that is. Is it infiltration or is it inflow? Are there direct storm connections, or is it from high groundwater levels and those kinds of things? So we've been able to pinpoint those as well.
Matt?
Yes, in terms of your computer modeling, especially in terms of stormwater drains, how are those affected during, and I know we're not in a full-blown drought yet, but this year, as rain flows are down in the since you guys started this study, how do you account for that?
Well, that's a good question, and that's where the stormwater side's a little bit more theoretical, because we're applying storms that we don't usually see. So I don't know the last time that the city saw a 100-year storm event. But we've got to take the information that we've got, and then we apply that 100-year storm event to be able to see what happens to the system. In terms of the water and the sewer side, it's a little bit different. The city actually sees its peak water demand every year, and that might be right around July 4th weekend, and it's going to see its peak wet weather wastewater flows every winter when you have a large storm. So. It's a little bit different on the stormwater side to be able to see that. There's also the other thing is there's also a better way to calibrate on the wastewater side. We've got flow data, what's actually coming into the treatment plant, so that's another calibration point that we're able to look at as well.
And I guess that's a natural extension when you think of the I&I with wastewater with the theoretical of stormwater. Since you don't necessarily know what that stormwater is going to bring, that's the theoretical side being put into the practical, realistic side.
Yeah.
Got it.
And just want to add a little bit on the stormwater side. What we're planning for on stormwater are infrequent large flooding events. So a 10-year storm, for example, you might want to keep that within the curbs of the street is a typical standard, where the 100-year storm, because it doesn't happen once every 100 years, it has a 1% chance of occurring in any given year. That storm, you might have you might let it flood a little bit more. You might want to keep it 1 foot or 2 feet below the finished floor of structures. So you let it come out of the streets, but you don't let it flood structures. It'll flood yards, non-occupied structures, that sort of thing. But you try to keep it out of non-inhabitable structures. So things like decks and pergolas, and those you might allow it to flood, but you wouldn't allow it to flood in a home.
Yeah. It's similar concept as a collection system model. We just ratchet down what that means in terms of a large event, right? We're keeping everything in the collection system, whereas on the stormwater side, it's a little bit different. Things can things can pond, and there could be some localized flooding, those kinds of things.
Red?
We've had questions recently about I&I. What did you discover from your survey? Are we at normal expected levels of I&I?
I'd have to go into the data a little bit more to get some real specific questions, but when we initially started doing some of the field investigations and talking with staff, the Cloisters area was one area that was discussed as potentially having higher I&I, and that's one of the things that the flow study did identify, is that that is a higher area of I&I compared to the baseline. I think in general, the city has kind of a little bit above average in terms of overall I&I. So that peaking factor that the city sees it's not, I mean, we've seen a lot higher, but I want to say it's somewhere in the realm of an 8 to 9 from the average to the peak hour flow.
About an 8, yeah.
Yeah. And we've seen 15s. I mean, we've seen larger peaks. So.
And based on some of the initial investigation, you've probably seen the publicity on our smoke testing that we'll be doing. So what we're doing with that is trying to pinpoint those areas of the worst I&I so that we can effect those repairs.
Anything else, Matt or Red? No? Marlis?
Yeah, I just wanted to follow up on this issue of the flows. You said that there has been a flow study. Can you tell me when that was most recently done?
Yeah, the flow study was actually started a little bit before we got under contract, I believe. I'm trying to remember the timing of it exactly.
February, I think we got the meters out in the system.
Yeah, I think, February, and I believe wrapped up, started to see some of the data and reports about June, July of last year.
So fairly recently. And can you tell me what the results were of that?
So the results of that, where we used that study to do, was to really to calibrate. It was used to calibrate the model. The nice thing, the city has its own flow meters that are out there in the collection system that were gathering data and everything else. So one of the things that we were able to do is not only did we have that snapshot in time that was back in February, March of this last year, but we were actually able to take the data from the flow meters that have been collecting data in the city for, I don't know how far we went back. I'd have to look at the flow study. But we were able to use that data, too, to even improve the data set that we were looking at to be able to evaluate and substantiate the flows in the system.
Okay. Maybe I should just follow up with Rob and say, and so what are the flows?
The flow study that VNA, a subcontractor or a contractor that directly to the city performed, didn't reveal anything different than what the Black and Veatch work revealed. So based on the statistics that were performed in that flow study, the average daily flow into the treatment plant was 0.96 or 97 CF. I don't have the flow study right in front of me, but it was very close to what was in the Black and Veatch analysis, and they helped us calibrate our influent flow meter at the treatment plant, and so we have good flows. As I've said before, average flows aren't really a design parameter for treatment plants. Various components, you use different flow regimes to design those components.
Right. No, I'm just trying to verify that we have the data and that it's fairly recent. And, of course, that included Cayucas, so I'm sure you made the necessary adjustments.
Yes, actually, the flow study that was used for the model is without Cayucas in the mix.
Thanks.
But yeah, again, I thought that maybe was what you were alluding to is how does it stack up, or how does it compare to previous studies? And we're actually very, very close in terms of what we're projecting as the future flow average flow conditions as previous studies. So
right.
Okay for questions at this point?
Yeah, just one more. Can you tell me how you're coordinating? You said you're coordinating with the WRF, and how are you doing that? How's that?
There's a couple of coordination points that we've had with them to date, and some others that we're planning to have. Most recently, there's work that's being done by the design firm that's working on the design of the new pump station in force main. So they're really interested in, number one, did our flow analysis and is our model showing a similar peak hour flow as what historical data has shown? And so that's something that we've been working with them on. They've actually asked us for some specific flows and specific parts of the collection system based on our models. So we've been able to provide them that. They're looking at some different scenarios and how that pump station's configured and everything. So that's probably been the closest coordination that we've had with them. And then on the water supply side, there's a couple of things that we're looking at in terms of there's some hydrogeologic work that could influence the way that we look at some of these future water supplies. So that's another coordination point that we've had.
Okay.
All right, great. I'll continue on. Thanks.
Good afternoon. So I'm going to talk to you about the water supply evaluation that we've been working on. So, and I apologize that half of you can't see it very well. This slide just gives us an outline of what the components of the evaluation are, and we've been looking at developing future demand projections, identifying alternatives, developing the evaluation process, which includes coming up with criteria as well as the methodology for comparing alternatives. And then we'll be moving forward into the evaluation of the alternatives, performing both cost estimates as well as qualitative comparison of alternatives using those criteria that we establish. And then we'll be recommending a suite of supplies and wrapping it all up into the One Water report. So I'm going to just walk through each one of these components that we have a little information on. So for the historical and projected water demands, for those of you who can see the top graphic, that's your historic water usage. And of course, it dropped off significantly through the drought, which does make it a little more difficult to figure out how much water do we need for the future. So your urban water management plan uses a per capita target of 116, if I can see that correctly from here. And that really assumes that you're going back to pre-drought usage. So we actually
Excuse me, 116 what?
Sorry, gallons per person a day. Sorry. Yes, that's your per capita water use. So when we looked at it, we came up with 106 gallons per capita per day. Yes?
Do we mind if we ask you questions while you're presenting?
Yeah,
Or-
that's fine.
In terms of the 106 gallons per person per day, are you also, is that commercial and residential, or is that strictly residential?
That's an average over the whole city.
Okay, so that would include both
That's
residential
both, yes.
and commercial.
Yes.
Okay, thank you. Somewhere along the road in this report, will we get a breakout of those two entities, commercial versus?
Yeah, we typically just are looking at what's the demands for the whole city.
Got it. Rob, I guess the question is for you then. How will we use this in terms of that idea, commercial and residential?
So the One Water is really a planning tool to look for our overall water needs for the city. We also do a water conservation report where we drill down into the detail of breaking down the various users and how much water. So we know our actual residential use is much less than that number. So
Got it.
We drill down for the detail for water conservation planning. This is for our overall water supply, where that big tank of water is going to come from that supplies the entire city, and then we drill down to the discrete data for how each of the users, which is really a little bit out of scope of the One Water planning effort.
Okay, so taking that historic data, then we have to project forward for how much water supply do we need in the future. So the bottom graphic does that. And again, it's complicated a little bit by the recent drought and the fact that most communities are talking about a rebound effect, that maybe water usage is going to come back up. So what's that starting point for how much water you need moving forward? So that's why you see that there's several lines on the graph showing projections moving forward, depending on, are you starting from, the lowest point in 2015, or are we assuming there's a little bit of a rebound for that starting point? But the end game then is that by 2040, we're anticipating between 1 and 1.4 million gallons a day of water supply need for the city. Okay, so we also are looking at a variety of water supply options. And I want to break these down into the categories because really we are trying to bookend the options for you. So I added in some colored graphics here just to kind of help you. So the first alternative is state water. That's what you're on now. Of course, it is an imported supply, which comes with its own associated, pros and cons. On the other end is ocean desalination, which of course also comes with its own pros and cons. And in between, we have our local options. And those really, when you talk about local supply options, it's stream flow or groundwater. And so we have those categorized into the Morrow well field, which is a groundwater supply, and we have a couple different kinds of treatment that we can put on it. Then we have the Choro well field, which is kind of a combination of stream flow and groundwater supply. I'll characterize that. So that's really how the different supply options are categorized. And then, then the other category using the Morrow well field is augmenting with recycled water or purified water from your new facility.
Questions?
Yes.
The Choro well field, we require a certain minimum flow before we can draw. So I'm not sure what you're saying. What does augmentation mean?
So the idea for the Choro well field is, yes, because you're right. You have certain minimum flows that have to stay in the stream before you can draw. And we were just talking about, actually, before we came over here, that there are different water rights holders that have priority to draw before you do. But one alternative that we've been discussing is that maybe you can take that purified water or your treated recycled water from your new facility, take it upstream, put it into Choro Creek, and then that would provide additional stream flow so you could pull more water out.
Thank you.
So that pretty much covers the suite of alternatives that we're looking at. So now I'm going to move to how we're evaluating that. And so we've come up with our water supply evaluation criteria, which are really important considerations for evaluation. And we've categorized them into 5 categories. There's economic considerations, natural hazards, resiliency, environmental, and then implementation. And then under each one of those, we have some sub-criteria that we're looking at. So for economic, we look at total project costs, operations and maintenance costs, and then present value. Under natural hazards, we're looking at earthquake risk, flood risk, as well as sea level rise. Resiliency, we're really talking about how resilient is this supply to drought. And then another criteria we're looking at is local supply benefit. So there's really 2 there. And then for under environmental, it really falls under energy use, and then affiliated with energy use is greenhouse gas emissions. And then finally, implementation is an important criteria for us engineers because we like to know that it's constructible and we can get regulatory approval. So that's a pretty important piece as well. Okay, so we take those criteria, and then what we're going to do is step it through an evaluation process to look at those alternatives. And so, as I mentioned, we have a cost part under economic. We also are looking at we are trying to allocate the percentage weight of each evaluation criteria that I showed you the criteria. And then we also are going to do a ranking of how each alternative performs for each of those criteria. So an example of the ranking is down in the table here, where we're doing a 1 to 5 ranking, where 5 meets the criteria to a high degree. So, for example, it's very resilient to drought. Versus the other end of the spectrum at 1 is that it's not resilient to drought. So we're carrying those 1 to 5, and we rank each of these. And then we're going to multiply the ranking, the 1 to 5 ranking, to the percent criteria score, basically a weighting, and then that comes up with a total alternative score for us. So for the water supply evaluation criteria, it boils down to essentially 9 criteria that we're evaluating, and we've worked with the city staff to prioritize these criteria. So I think Rob wanted me to pause on this slide for a little bit and let you have a chance to look at how we prioritize the criteria. But I'll read it to you since you can't see it. So we said the most important criteria was cost in terms of, and the metric that we're using is unit cost in dollars per acre foot. Second most important criteria was drought resiliency. Third was earthquake resiliency. Fourth was flood vulnerability. Let me know if I'm talking too fast too, because I see you're writing it down. 5 was local water supply offset. 6 is energy requirement. 7 is constructability. 8 is regulatory and institutional complexity. And then 9 is quality.
Lydia,
Yes.
this particular presentation, will all these presentations be available for us?
Yes.
Okay. And when all this evaluation criteria is complete and we have a one water plan, and I think I might be jumping ahead of you as far as next steps. Are you going to get to the next steps as we go through this? Okay,
Yes.
I'll wait then. Okay.
Any comments or questions on the criteria?
Yes, I do have one on the criteria. Are there any sort of, and in terms of the criteria 1 through 9, is they ranked in terms of the highest, most important from 1 to 9, or are they all equal?
Yeah, at this point we have them ranked from highest importance down. That's how they're shown on the slide. So if you have input on, if you think our team's assessment is wrong in those priorities, we'd love to hear that.
I guess I would say so, but I certainly wouldn't put quality last in that list. To me, it might be up there at number 2 or 3 at least. But I think it's an important criterion for the community. And I'm not sure what you mean by quality. If you're talking about, does it contain substances that are dangerous to your health, or are we talking about the taste of the water? Because that's really important to the community as well. So you'd have to really define quality, but I would certainly put that higher on the list.
Well, and I do want to certainly qualify that for any alternative, for it to pass the initial straight phase test, it has to meet regulatory requirements, right? So if it doesn't meet drinking water standards, then it's not a viable alternative. So that's probably, I'm trying to remember why we ranked it at lower, but I think that because it inherently in meeting the regulatory requirements, it meets the quality. That was probably why.
I think from what I recall, the quality we're talking about here were more aesthetic quality. It may be harder water than, for example, desal water or state water is very soft water, very low in mineral content. Folks that have been in Morro Bay for a long time remember when we were delivering local groundwater without running it through the brackish water RO. Very hard water. Had a lot of problems with, but it met all the health requirements. It just was not the optimal hardness.
Yeah, I think oh, no, go ahead.
Go ahead. No, I was just going to say, we have experience when we're off of state water, and we have the entire community complaining about the taste of the water, the color of the water. And so, to me, quality of the water, if it includes those elements, it might meet state standards, but still, the community is not going to find it acceptable. So, to me, quality is quite important as a criteria.
Part of it is the aesthetic qualities, but the other thing to take into account, and one of the reasons why quality is kind of lower on the list, is that to a certain extent we can kind of mitigate the quality issue. We can really take any water of these water supplies and make them a very high quality. It's really a trade-off with cost, and so that's where taking any of these individually on their own, it's a little harder to see how it's relevant unless you look at the whole picture. So, for example, we've got a couple of different of options for, say, the Chorro Valley stream flow augmentation. So, and again, we'll talk a little bit about next steps and how some of the hydrogeo work will help us narrow down some of these alternatives. But one of the things would be, if you were to use that Chorro Valley stream flow augmentation without any kind of treatment, there is some risk to the water quality in terms of getting out of parameters, higher TDS, or getting close to the nitrate limit. Whereas if you put in some type of nitrate treatment from that water that's coming out of that Chorro well field, you're pretty much guaranteed that you're going to have a high quality water all the time and not have to worry about those things. But that's reflected in the costs. So a more stable quality, or maybe a more reliable quality, is essentially reflected in that unit cost number. So that's where, taking all of these together, you can kind of see how those different things play against each other.
Some of our discussion as staff and the team is you could basically relate all of those to cost. You could produce the same water quality from each of the alternatives, although one might be exponentially higher than another one would be to get that same quality.
If I could ask a question, but however, I think there's one in terms of the hierarchical scale, is energy requirements. When we talk about unit cost for state water, to get the water here in debt and maintenance, I can understand acre foot and cost per acre foot. But for instance, when we do have our state water shutdown, when we are using our brackish water and our desal, it's very energy intensive. And so I could see putting number 6 as a sub-consideration of number 1. And I realize we can mince words and get caught up in the weeds here, but that energy requirement in terms of either A, getting the water here or treating it here is significant.
Yeah, and maybe this is an issue of next steps and how we maybe add more input into this, and we can have that discussion later.
Could you just really quickly define local water supply offset as a criteria? What is that?
So essentially, if you look back at the list of options that we're looking at, all of them are essentially local water supplies except for State Water Project. But we're trying to come up with a metric to say how much is it helping your local supply? Is it meaning that you can come 50% off of state water or 100% or, right? So we're kind of trying to compare that to what's your total demand that you need to meet, and how much can be made up from a local supply.
Any more questions? Okay, thank you, Lydia.
And I think I have another slide, but just kind of teeing off of the previous conversation, you'll see that a lot of these criteria are intermixed. I mean, energy is absolutely a piece of cost, and local supply offset is a piece of drought resiliency, right? So it's difficult when we're trying to come up with criteria to compare. We want to try to be discrete as possible, but they definitely do overlap each other a bit. All right. Okay, so just the quick status update like Eric did on his slides. We have completed identifying the alternatives and laying out those evaluation criteria, which we just showed you, finalizing the evaluation process. We're in the process of doing the cost estimating right now, and we're trying to get a better handle on State Water Project costs and reliabilities. We had a call with the county about that in the last 2 weeks. And we're developing the ranking values and the weighting, and so then we can come back with our evaluated alternatives and show you what they look like and come up with the recommended options moving forward. Okay, and I think that's it. And Eric's going to talk about next steps for the whole One Water plan, unless there's more questions on water supply.
Any other questions? Thanks, Lydia.
So hopefully, Mr. Mayor, this answers some of your questions. So again, going back, focusing a little bit more on the infrastructure side, kind of where we currently are in terms of next steps, is really digging into those short and long-term deficiencies of the system so that we can come up with the cost. Kind of a snapshot of where we are right now. We're kind of knee-deep in that exercise. And then the next is really to present the water supply alternative costs to staff and have essentially a workshop with staff. I'm kind of jumping down to the next bullet, which is a water supply evaluation workshop where we've now gone through and we've identified the criteria. We have some prioritization. So we've got some weighting. We've gone through an initial assessment of, state water is a 2 for drought resiliency or whatever that might be. We've gone through that exercise. We've got the draft costs. We've compared it to other documents that are out there, other planning documents that are out there for consistency and looking at how those things interrelate. It's really to have an internal workshop to go over all of that information with staff and refine anything that we need to with staff before we come back and essentially do that next step, which is to report back and report back with some more kind of results versus, this presentation is really focused on what are we doing, what do we need to do now, what do we need to do in the future, kind of where we are in the process. The next time that we come and talk to you, it's really going to be, here's what our initial results are showing in terms of how are the different evaluation criteria playing out for these different options, what do the cost numbers look like between the different options and those kinds of things. So a tentative timeline right now would be within the next month or so is to have that workshop with staff, and then first go through like we did with this presentation, have an initial presentation to Public Works Advisory Board, PWAB, maybe in right around the March time period, and then follow that up with a very similar presentation to you folks the next month, maybe in April of this year.
And when you say update, I'm envisioning a document that is a one water plan. Is that update kind of going to be kind of a draft version of what we expect to see?
I don't know if we're going to be delivering a draft of the document at that time. It's really to go over a lot of the content or the big picture items in there. For example, what we would come back to you would be, we've taken a look at the existing water distribution system, and right now everything is okay. There's no real immediate need for any projects, but over the next 25 years, here are the 10 different projects you've got to do. You've got to build this new tank. You've got to upsize these different pipelines in different parts of town. And here's what we think the cost impact of that's going to be, and review that with you. Similarly, on the collection system, these are the pipes that are deficient that need to be replaced. Here's the new lift station that needs to be built, or whatever that might be. Go through those different things. Here's what some of the cost impacts might be. And then on the water supply side would be to go through and say, we've taken a look at all these things from a qualitative standpoint. Here's how the different water supply options, which there are 7 or 8 of them, here's how those stack up against each other for specific criteria and then overall. And then here's what the dollar cost per acre foot are. This one's $1,600 per acre foot. This one's $12. This one's $18. This one's $2,000 per acre foot. And review all of that, but not necessarily we may not have the conclusions, which is this is how the process should move forward, but it'll have kind of, here's what everything that's going to be in the draft document from a technical standpoint and from a cost standpoint.
So when should we expect a final document?
That's a good question. In terms of depending on how this shakes out, if we can stick to this schedule, we're probably talking about another month or 2 to deliver a draft document. Once we go through this exercise in February, March, and April, we get consensus on how that document should be framed out in terms of the recommendations.
So June, July would be a draft document?
Yeah.
And then beyond that, September, August, or something like that, a final?
Yeah, something right around then would be fine.
Okay.
And I think that follows the original schedule that you had in your scope of work.
Yeah. Our schedule is right around 12 months.
Yeah, 12 months to deliver the final product, and we issued that contract in August of last year.
Yeah.
Other questions?
I have another question. Yeah. One of the alternatives I know involves the recycling and reusing the water by injecting it back into the Morrow Basin. Yeah. And I just want to be clear on what additional research or studies might need to be done to see if that's a viable approach. And secondly, how would we know what the quality of that water would be after we do that? Is there a way to test that, or is additional treatment going to be necessary? I'm just curious to know how we know that.
That's
or would know that.
That's a great question, and maybe I'll just back it up to this slide right here. So one of the things that we have on the next steps is we're going to, or the city is going to be doing some additional hydrogeological studies. One, to inform what's happening on the WRF side, but then also to help us limit the number of alternatives that we're looking at. So, for example, the reason why we have the 2A and 2B, the 3A, 3B, 4A, 4B, is because we don't necessarily know. So a good example is what you're talking about, which is the 4A alternative, which is the indirect potable reuse, is the injection of the water into the ground.
Right.
Based on the work that's been done, it's not completely clear if that water, when it's pulled out at the Morrow well field, if it's going to require additional treatment for nitrates, if it's going to require additional treatment for salinity control. And so that's why we're carrying those three different options, is because the timing of it, by the time we finish the one water plan, we will be able to just have a 2, a 3, and a 4. We won't need a 2A and a 2B because we will have answered the question, hey, when we pull that water out of the ground at Morrow, after it's been injected into the ground, it doesn't require additional treatment, and that's the work that the hydrogeologic modeling, a portion or a component of that will be water quality modeling. And so to answer your question, that's how that's going to be answered. That not necessarily testing, but that hydrogeological modeling will say nitrates will be a problem, TDS will be a problem, or not.
As you might recall, the assumptions in the Master Water Reclamation Plan would be that water would need to run through the brackish water RO prior to distribution. Based on some additional work from GSI Water, that may not be the case. We may not need to run it through brackish water RO to achieve that same water quality, but we need to complete that fate and transport, so determine how these constituents migrate through the aquifer and what their levels are when they're withdrawn out. It's not really testing, it's modeling. And the modeling has been proven out time and time again, comparing it to actual results. So we have confidence that the modeling will be able to predict what future capital improvement projects will need to do.
And would we know anything about what that water is going to taste like?
Taste is a little bit subjective, unfortunately. I can tell you it'll taste like water.
Well, it's important to the public how it tastes.
So one of the major components of taste that we got complaints on last time was because we changed our disinfection method. So we went from a chloramine disinfection method to free chlorine. I live in a community that uses free chlorine. I drink that water and really can't taste the difference between chloramine and chlorine water, but there are some folks that really can taste that difference. Maybe I have no taste is the problem.
But I guess your answer is that you can play with it and change it by what you add or take.
Exactly. It's really taste is much a part of the disinfection method that we choose to use at the end of the process.
Yeah.
John, you had some questions?
Yeah, I did. Thank you. So one of the questions. Go
Can I
ahead.
just ask one more?
Oh, yeah.
Yes.
Quickly.
Sure.
Before it leaves me. I'm a little slow here. I just want to know how we could reevaluate or look at this prioritization moving forward before you complete all of this. Is there any way that we could submit comments or provide input aside from what we've just done?
Definitely, and we'll make the slide presentation available on the website for the public to provide comment and for council to provide comment to us, and that'll be reflected in our next presentation to BWAB and to the
I'd like
council.
that.
Yeah, I would also
Just for the record, if I could just say, I need to understand how the council is going to make comment? Are you saying they're going to submit comments to you, and then you're going to incorporate in whatever you present back to the whole council those comments?
That's correct.
Thanks, Joe. You're awesome. And I think it's important as we understand kind of the ranking. I expect that PWAB, that may or may not be some subject, and I expect that looking at the ranking, we're not necessarily experts, but there's descriptors in there than why you rank them to begin with, and that's probably helpful for us if we have concerns or want to have higher understanding of the rankings themselves. But it seems like it's appropriate that during this process we'll get some feedback, and hopefully the feedback on prioritizing those are with high understanding.
Yes, I think in the next presentation we'll add a little information, maybe a little definition of what does it mean by local water supply offset. What do we mean by? Well, we all know what it costs. That's the easy one.
Yeah.
Okay. Sorry, John.
I'll leave it at that.
You're sorry.
No worries. Thanks. Just a follow-up to the IPR question. I'm assuming that you're using data from the master plan to look at costs associated with the endpoint of the IPR 3 alternatives that you had there. Or I should say maybe the Morro Valley sources and the various options, and that's coming from our existing plan for the new plant.
Yeah, no, I would say yes and no to that. We were charged with kind of coming up with an independent cost estimate. We're looking at a very similar project, and so we kind of took a look at it on our own based on our experience with potable reuse projects, other planning studies. So we've come up with a cost estimate, and we are looking at that and comparing that to the work that's previously been done. The initial assessment is those are actually very close from a capital standpoint, and we've been working through some of the small differences on kind of the O&M side with staff. But yeah, we kind of took an independent look at that and are now going back and validating those against the previous costs that have been presented.
Great, I appreciate that. Second question is, this is a 20-year look at CIP needs down the line and from each of the sources and what the city might incur in terms of cost associated with those CIPs. From what I understand and what I've just heard, the question is this: with regard to that, how do you build in accelerators, and do you just use a standard accelerator in terms of cost modeling? How do you handle debt service? How do you look at city finances and determine source of funds, et cetera, et cetera?
I would say a little bit of that is kind of outside of the scope of what we're doing. We'll come up with the costs and when those projects need to be initiated, when they need to happen based on the information that we have. And then I think the timing of this, I think, dovetails nicely with the rate study work that the city is currently doing. And so we were just having a conversation about the timing of when we think we might have those CIPs available. And then that would be for the rate consultant to then take the cost of those projects, how they're allocated between existing future users and different types of users, residential, commercial, and then crank those into their model. And so we're really providing something that goes into their model so that they can answer those types of questions of, this $2 million sewer line that needs to go somewhere in the city, how does that really translate into the dollars per resident, how that shows up, how that gets, how that works into the rate structure.
Good.
Just to add on a little bit to that, also, the last time we did a water master plan was 1995. I think the key to that is to do these fairly frequently, so do updates every 5 years so that we stay more current on our costs and what the needs are of the system rather than every 30 years.
I absolutely agree with you in that. Second to last, and this is a quick question, I promise. This state water supply costs, just curious, how in the heck are you determining 20 years worth of costs on state water?
We've got this crystal ball that we use. No,
Thank you for that.
No, actually, it's something that we've been wrestling with we've been wrestling with this since we started the project. We've got some precedent from other projects that we've worked on in terms of our work for the One Water LA project. And actually, Metropolitan Water District has done a pretty good look at kind of the latest view of what the California Water Fix is supposed to look like, and how that California Water Fix cost gets appropriated to the Central Valley Project, to the State Water Project, and then based on allocation, what does that long-term cost look like? And so we're currently working through that financial model. State water is the cost is kind of a tricky animal because you've got debt service that you're paying for the local facilities, you've got debt service that you're paying on the larger bureau facilities, you've got fixed O&M costs, you've got variable O&M costs, you've got drought buffer, all these different things. And so that's what we're working on kind of right now, is to refine that and bring in what those California Water Fix costs may mean to the long term. And because actually a number of the debt service components of the city's existing state water rate are retiring, one, the local in 2021, and then the bureau in 2035. So we have to take into account all of that as we're looking at this long term.
And I assume the last question is DPR is not on there because there are no regs, and you can't. Your crystal ball doesn't allow you to assume that might be an option down the line for this city in 20 years.
That's a good question. That theoretically could be something that we could look into. Yeah. Might
be an addition.
Got some idea of what DPR is going to look like.
Exactly. I'd like to know. Yeah. Great. Thank you.
Okay, Red.
Regarding the evaluation criteria, I agree with Marlis. I'm very concerned about putting quality at the bottom of that list, because that's going to be a red flag. That's going to be what people are going to focus on, and that's going to be all they're going to talk about if they see that we put quality as the lowest ranked criterion. The questions that I hear from people about IPR is, well, if you pull it out of the Morrow wells, is it going to taste as bad as it used to before state water? So that's a big concern in the city, and I hate to taint the impact of this study by presenting that as a rallying cry. So I would move that up the list right now.
Good feedback. Thanks. Anybody else? Just a follow-up question on on John's comments, particularly about state water. And when you were talking about, well, Eric, maybe your comments on state water. So that would it be fair to say different municipalities out in California that are doing those types of studies, that are looking at what those future costs are, would you say that there should be caution that if LA is doing it or Oxnard's doing that, there might be some base data that may be informative, but everything's going to be different? Is that fair to say?
Let me make sure I understand exactly what you're saying. I think there is, based on the latest data, I think there's a pretty good handle, or at least on how the project currently sits. There's a pretty good handle on what the capital cost of the California Water Fix is going to be, and then there's a pretty good estimate on what the long-term O&M costs are going to be. And so I think that really, I mean, Morro Bay would just be, or not, their rate impacts are not going to be so different than what Metropolitan Water District's impacts are. Now, they use 50% of the state water project. It's a proportion. It's a proportional thing based on your allocation. So your 1,300 feet versus I can't even remember what exactly the number of acre feet per year that they use, but it should be fairly proportional. And so that's what we're validating right now is, okay, we've got some pretty good data points on the overall cost and in terms of construction cost and the overall O&M cost. Now, granted, that's a snapshot in time for what the project currently looks like, but we can look at that and apply that and try to figure out what those costs might look like.
All right. Unless there's any other questions. Marlis, it looks like Marlis might have just one more question.
Yeah, no problem.
How do you estimate the probability that thing is going to get through?
That's a good point.
I mean, It's one thing to have an estimate of cost at this point, but so far it has not had a lot of traction. So I'm just curious to know how you figure that one out.
Yeah, I guess in looking at it in that way, then, there could be the opportunity to look at state cost without the California water fix and maybe what the long-term cost of state water might be without that. And then the opportunity to look at the cost with the California water fix as it currently sits. So that would be kind of another, kind of sensitivity analysis to say, it looks like it's $1,400 an acre foot or $1,600 an acre foot with that. So, Lydia, you have some? Yeah, absolutely.
I think it's just important to note that one of the big selling points of the California water fix is it's supposed to improve the overall reliability to at least keep it at what it was historically. So with climate change moving forward, I think if we were going to carry a scenario of state water without the California water fix, we would have to be then trying to make some estimate of reliability going down in the future. So it starts getting very much that crystal ball that Eric was talking about.
Okay. I think if we're close to wrapping this up, any closing?
Thank you very much for your time.
Okay.
Appreciate it.
Yeah.
All right, thank you.
Thank you.
We have open and closed public comment, but we do have a speaker slip from Mr. Brannon. You want to come up for public comment?
Thank you, Mayor Irons, for giving me the time. I'd like to look at two things that we talked about. We'll talk about them later, but they had a graph showing water use for the city. And I don't know if you could put that back up, but good to see. But the other item, if we don't get that, is the speaker talked about the amount of infiltration into our system. And they were comparing what our city is on a number versus what the average is. And I think the number he used for us was 15 and the average was 8. I don't know if that's exactly right, but it sounded like our infiltration was very unusually high for our city. So I'd like that to be kept in mind for our future discussion later on C2. But the water use drop, we had, I believe there was 4 years of such a dramatic drop, and to not equate the fact that we had a water rate increase about the time that water volume dropped, and to not keep that in your mind when we get to the C2 discussion that's coming up later tonight.
Thanks, Barry. We'll close public comment.
Just to clarify infiltration, we have about an 8 times a peaking factor, so average flow to peak hourly is 8. Mr. Caceres said he's seen as high as 15. So ours is not atypical for communities. Yes, we have seen a drop in our water usage due to the community doing a great job on water conservation, but we are also seeing a rebound effect as water supply is more prevalent and the kind of more draconian conservation measures are no longer in place. Folks will start using more water. They will start using more water because they enjoy landscaping around their house. Now, all that outdoor water use does not affect sewer flows.
Okay. All right. With that, unless there's any other comments or closing comments on this, we can adjourn this portion of our special meeting. Looking for counsel on that. Are we all good? Okay, thanks for the update on this. We look forward to the update as it comes back in around April, and then we'll look at a draft and final around August, September from what I got out of that. Thanks very much. We'll call this meeting adjourned. Thanks.